Hi guys, I'm Tiffany from Steps Academy Math and Science Center, and today I will be continue teaching you guys organic chemistry. So if you guys didn't remember, last video I actually introduced organic chemistry to you guys. So today I will be talking about crude oil and alkane, and the next video I will talk about alkene and additional polymer. So let's get started. So I actually made some note on crude oil already, but if you guys do not remember, I said looking at the spec is actually really important. Looking at the spec will make sure that you know every single point on that topic. So yeah, and I'm just gonna go through crude oil with you guys. So let's go. So 4.7, know that crude oil is a mixture of hydrocarbon. That is literally the same as 4.1 and literally tell you what you need to know for that point. Crude oil is a thick and sticky black liquid that is found underground in sea. It's a complex mixture of hydrocarbon. An example of crude oil would be this. I'm so sorry, it's lagging so much for some reason. So an example of a crude oil will be C5H12, give you 8OH, and then give 5CO2 plus 6H2O. And you will know what C5H12 later on when you learn alkane and alkene. For now, you don't have to know it yet, but it is an alkane and it is pentane. So you're going to learn that later on when you learn alkane, so it'll be easier. So I'm gonna move on for now. 4.8 describe how the industrial process of fractional distillation separate crude oil into fraction. So fractional distillation definition, they might ask you in an exam, but may not. So it really depends. Fractional distillation is to separate two or more liquid that are miscible with one another. So they basically separate crude oil into so many different other gases or oil that are important and that are important for the industry. So as you can see in this picture, crude oil actually come from here. They get heated and then they will go to different single gases that will be used later on. And I will show you guys what I mean in this table. So I will talk about 4.9 and 4.10 together so that it makes sense. So 4.9, know that the name of you and uses of the main fraction obtained from crude oil, and these are like the example that you gotta know. 4.10 is know that the trend in color, boiling point, and viscosity of the main fractions. So this is basically the graph that you would need to know for this 2 points. So what is viscosity? You probably have no idea what it is, but it actually refers to the tendency of a substance to vaporize. So is it like thick or is it really thin? So that is basically that. So I'm not gonna go over this graph because you guys could see it yourself. But the thing that I would tell you guys is that color, it will get darker as you go down the column. So this is called fractional column, and this process is called fractional distillation. So color are the only thing that it will go darker when it go down the group, because flammability and viscosity, it will go it will get like thinner, and it will get, okay, let me say it like that. So viscosity, it will get thicker as you go down the group, and flammability, it will get less flammable as you go down the group. So I'm just gonna write down that so you guys would remember. It gets thicker as you go down the group. It gets less flammable But as you go down the group, it gets darker as you go down the group as well. So this is just something that you gotta know. They love asking you, oh, what's the uses of like bitumen? So you gotta know. Now, I'm not gonna go through it because it's literally in front of you. So yeah. So let's move on for now. 4.11, note that a fuel is a substance that when burned release heat energy. Sorry. That is really, really simple. Sorry. That is really simple. It literally tell you what you need to know. It literally tell you what you need to know for that point. Sorry about that. I literally choked myself just now. But fuel is a substance which, when burned, release energy, and those energy can be transferred into electricity in our daily life, and that's how they work, and that's what you will learn more deeper knowledge in physics if you guys take physics. So 4.12. Note the possible product of complete and incomplete combustion of hydrocarbon with oxygen in the air. If you guys don't remember, I already talked about that in the introduction, but I'm just gonna remind you guys once again. Complete combustion is there is unlimited supply of oxygen, and it will give off CO2. It will give off carbon dioxide. While in complete combustion, there is a limited supply of oxygen, so it would come out as carbon monoxide, which is poisonous. And I will talk about why it's poisonous in the next point, which is this. 4.30. Understand why carbon monoxide is poisonous in terms of its effect on the capacity of blood transport oxygen. So I basically say carbon monoxide reduce capacity in hemoglobin to transfer oxygen into the blood. If you don't want it to be that complicated, you can always say carbon monoxide reduce capacity of blood to carry oxygen. That will already give you 2 marks. But mostly I write this too because my teacher did tell me to link to hemoglobin, even though the point didn't say you don't need to, so that's a bit weird, but I would prefer you guys just remember that one, and that would just give you 2 marks. And they love asking you that question, guys. They love asking you why is carbon monoxide poisonous in the test. So yeah. 4.40. Note that in car engines, the temperature reached in high enough to allow nitrogen and oxygen from air to react, form nitrogen oxide. So when fuels are burned in car engines, nitrogen plus oxygen in the car will give you nitrogen monoxide, and because there are oxygen inside the car, so that it could like move. So when it burn, it would just react together. And when nitrogen monoxide is actually released from the engine, it will combine oxygen in the air to form nitrogen dioxide. And this is the formula that you guys got to know. And yeah, I'm pretty sure that's pretty simple. I mean, there's nothing to like really talk about. So yeah. 4.15. Explain how the combustion of some impurities in hydrocarbon fuels result in the formation of sulfur dioxide. So hydrocarbon fuels is impure hydrocarbon fuels contain sulfur compound. So that's basically containing sulfur, this a thing. So I'm pretty sure you guys know what sulfur is on the periodic table. So combustion of hydrocarbon fuel would give sulfur plus oxygen, give sulfur dioxide. So again, it will react with oxygen in the air to give sulfur dioxide. And yeah, and don't these are some formula that you guys just got to remember. There is like no easy way to remember it, of course, and like you don't really need to like understand it to remember, because they tend to like will not ask you what's the formula of combustion of hydrogen fuel. They wouldn't ask you like that, but you got to know this formula. You just need to know it, but you don't need to remember it like 100% because I've done so much past paper. I don't think it really come up, and if it come up, it would just tell you to balance or something like that. Okay, so 4.16, understand how sulfur dioxide and oxide of nitrogen contribute to acid rain. Okay, so acid rain, you probably have learned that in the acid alkali topic, but acid rain is rain that contains dissolved acidic gases. pH value of acid rain is approximately 3.4. Guys, of course, the rain that you're having, like weekly, monthly, are not acid rain. Okay, guys, acid rain is so dangerous. It literally damages so many things. So contribution of sulfur dioxide and nitrogen oxide to acid rain. Sulfur dioxide plus oxygen plus water give you sulfuric acid. It literally rain acid, guys. And nitrogen oxide will dissolve in H2O in cloud because like the gas will kind of evaporate, and then it will react with the cloud. And so that's why nitrogen dioxide with plus water give you nitric acid, guys. It literally give you acid, so that's really dangerous. Effect on acid rain. They love asking you that question. What is the effect on acid rain? It kill plant and tree. It destroy building, and it kill organism that live in the sea. So yeah, and that is something that you guys gotta remember. Okay, 4.17, describe how long chain alkane are converted to alkene and shorter change of alkane by catalytic cracking. I have mentioned catalytic cracking in the last video as well, but this will be more in detail. So catalytic cracking is simply just splitting large molecules into smaller ones. That is basically it. It breaks a whole large thing into a smaller things, and it allowed large hydrocarbon molecule to be broken down into smaller one, more useful hydrocarbon molecule. Basically splitting large molecule into smaller one. That is basically it. If you want it to be better than smaller and useful ones, okay, it need two things. And you have to remember this two thing. They love asking you this question. It is heated in 600 to 700 degree. It need a catalyst. I love, if you guys didn't remember, but I did say I love saying Al2O3, and I say Al2O3 for every single one, and I get it right. So just say Al2O3. If you want, you can remember silica or alumina, but I wouldn't recommend that because Al2O3 is so much easier to remember. So yeah. 4.18, explain why cracking is necessary in terms of balance between supply and demand for different fraction. Yes, we're talking about supply and demand here, and it's not that difficult, guys. So basically, short chain of hydrocarbon burn and flow super well, better than long chain. Cracking is used to produce petrol for cars, and it produces alkene, which are raw material in plastic industry, and we will talk about that when I talk about alkene. So there's a higher demand for short chain hydrocarbon, but there are higher supply for long chain hydrocarbon. So that is why we have to do cracking, because there are higher demand for shorter change. That's why we have to break down the longer change to meet those demand. And an exam question will probably ask you like, will give you C6H14 and C4H12, sorry, C6H14 give you C4H10, and then they will ask you plus C something H something, and that's just basic math. It's just that 4 plus 2, 6, 10 plus 4 equals 14. So that's basic math. I'm pretty sure all of you guys could do it. So, and one of the questions that I get asked the most is probably explain how fractional distillation work. As I said, one of the most famous questions that they love to ask you is explain how fractional distillation work. So basically, it usually is 3 to 4 to 5 mark. It come into ranges. So this is what I am going to say if it's a 4 mark. I would say crude oil is heated and it goes into fractional column for it to separate. That literally will give it 2 mark. Because heated give you 1 mark, goes into fractional column for it to separate, 2nd mark. Gas that vaporizes and rises through the fractal tower, hot at the bottom and cool at the top, and the oil cool and condense at different height where liquid can be collected in trays. So that would give you three and fourth mark. So gas vaporized, this will give you 1 mark, and then this will give you the second mark. Of course, you don't write bracket when you're in an exam, so you could just say, and they will be separated from hot at the bottom and cool at the top. Or you could just say it gets, cooler as you go up the fractional. Column. And that will give you the 5th mark if you ever write that, and don't write that. So, yep. And that's it. That's just one of the pretty most common asked question in the paper. So now let's move on to alkane. But I'm pretty sure alkane wouldn't be coming to like strange to you guys because I did mention a lot of alkane like beforehand. But you wouldn't really know what is going on yet. But now I'll tell you this 4-point in alkane, and hopefully you guys will understand what alkane is like. So alkane is 4.19. Know the general formula for alkane. So I did mention what is general formula. So basically general formula is where everyone actually just basically uses that formula a lot. So all of that group, the whole group uses that formula to form that alkane. So you probably will be like, what the heck are you talking about? So the general formula for alkane is CnH2n plus 2. So basically, if you know how much C it is, which I will talk about, then you just sub the number of C. Let's say methane. Methane have 1 C because you guys would know from the table that I have shown you previously here. You would know this by knowing this table. So methane, you will know, oh, there's 1 carbon. So you basically sub 1 into the N. You sub 1. So N will be equals to 1. So C1, you don't write C1, you just don't write. You just write CH, and then 2 times 1 is 2, and then plus 2 is 4. So CH4 will be methane formula. And as you guys could see here, let me show you guys. And this is also what you need to know for 4.21 as well, but I will talk about 4.20 first. So 4.20 is explain why alkane are classified as saturated hydrocarbons. So alkene are not saturated, but alkane are saturated because all of the bonds are single bond. You can't see any double bond in alkane, so that is why it is considered as saturated. And so that's why it's considered as saturated. And now I'll be talking about 4.21, and hopefully 4.19 will come into a better knowledge. So 4.21 is understand how to draw a structural and display formula for alkane with up to 5 hydrocarbon in the molecule, and to name the unbranched chain isomers. So basically you don't need to know the last one. And I'll try to crop that so that you guys don't have to know. But basically you do need to know the first 5. And it is, so you guys can see it more clear. So basically this is the table that you got to know. You don't really need to know the state, but it would be great if you know as well, because they love asking you what is the state of ethene, propane, and room temperature. but you don't have to know it for now. So this is what I'm talking about. All of these formula are shared with this general formula. So if you don't get it, then I will show you an example, like C2H6. So there are two carbon, so you sub 2 into N. So 2 times 2 is 4, 4 plus 2 is 6. And this is how they work for propane, butane, pentane, hexane. They're all the same thing. So basically that is what you do. And yeah, I have no idea, guys, why. Okay, so here you go. And you do need to know the structure formula, but let me tell you guys, the structure formula is really easy. Like, let me tell you, alkane is probably the easiest in structural formula. You just basically draw the C in the middle and then draw how much H there are. But remember, it's only single bond, so you only draw one branch, one branch, one branch, one branch, like that. So it's basically like that. I don't think that is really hard, not gonna lie. But I will also show you guys their I'll also show you guys their structural formula as well, because this is their display formula and this is their molecular formula, but you will be asked for structural formula as well. So if you guys don't remember, I did tell you guys what is structural formula. So structural formula. So I wouldn't say like methane, alkane, ethane like this. I would just write for each one so that you guys would know what I'm talking about. So methane, they're really, the structural formula is the same as the molecular formula. So I'm just gonna say same. So and then for ethane, it will be CH3CH3. Because if you guys don't remember, I said you have to draw a middle line and then you just see this side and that side. So for propane, it will be CH3, CH2, CH3. Does it make sense, guys? Because you separate into different you just draw a line here and then draw a line there. So it will be CH3, CH2, CH3. And for butane, it will be CH3, CH2, CH2, CH3. And I hope that makes sense, guys. So I wouldn't do pentane anymore because I know you guys probably understand how it goes. So 4.22, which is our last bullet point for this video, I will be talking about describe the reaction of alkane with halogens in the presence of UV radiation limit to mono substitution. If you guys don't remember, I did say alkane, it will only happen in substitution. Substitution only are with alkane, and combustion could be alkane and alkene is addition. So if you don't remember, it's okay. We will talk about that here again. So this is substitution. Reaction of alkane with halogen. So remember, it has to be under UV light. I'm pretty sure I have mentioned it in the introduction as well. I said it has to be under UV light, and they love asking you guys. They would be like, what do you need for substitution to happen? You would say UV light. So under UV light, methane will react with bromine. So I'm pretty sure I have mentioned this in the introduction, guys. If you don't remember, let's go back. Remember here? here, and this is catalytic cracking, and this is substitution, require UV light, and this is methane. So I'll just copy that for you guys so that you have another note and just recap back what you need to know for that. Methane will react with bromine, and bromine is one of the halogen which you will learn in the when you learn halogen that topic. Methane plus bromine will give you methane plus hydrogen bromide. And why does it cause substitution? If you guys don't remember, it's okay, I will say it again. It's called substitution because it sub away the H into Br, and H will react with another Br because bromine is Br2, and you will know why it's Br2 when you have when you learn halogen that topic. So Br is Br2, as you can see here, bromine is Br2. So that's why it sub one of the H's into S into Br, and then another H will react with the other Br. So that is why it's called substitution and not addition, because it didn't add anything new. It just sub into the old one, if that makes sense. So I hope this video is not too complicated for you, because let me tell you, addition polymer is probably even more complicated, but I would definitely try my best to explain this well. So next video I will talk about alkene and additional polymer with you guys. So I will see you guys really soon. Hopefully organic chemistry isn't too bad right now. See you guys.